In this video, I'd like to take a brief look at string formatting. This is something that in the classroom we often just play around with, but since we're not in the classroom right now, I just put together a little slideshow. We'll talk our way through it, and then again at the end, like we do in so many other videos, we'll do a little work in the terminal window. Now, let's imagine that I have a little variable here called friend, scalar variable, and I put the string Bill into that. And what I would like to do with it is embed it into a bigger string. Here I've called it statement. So because the value friend might change to, I don't know, Ben or Sarah or Kit or Jonathan or whatever, I want to be able to embed the current value of friend into the bigger value of the string called statement. So in this case, I want Bill to be copied into the string. And so in statement, I would like to have a little bit of a placeholder or a template that will tell Python, go take the value of friend and put it into the bigger value of the string called statement. Now, traditionally, we could do this. We could just concatenate those things together. So I could split the string up manually by myself and add in the current value of friend. That's just traditional concatenation, the way that we've seen it. Does that work? Yes. Is it still okay? Yes, it is. However, Python and other programming languages have a slightly more sophisticated way to do this. You can think of it kind of as maybe a templating system or a placeholder or something like that. In general, it's called variable interpolation. And so if I want to interpolate a variable into a bigger string, this is the technique. Now, there are all kinds of ways to do this in Python. There are old ways and there are new ways, and I'm just going to show you two as we go ahead. But again, here's the idea. In this greeting string, I would like Python to recognize the word friend there in greeting. Hello, friend. I would like Python to recognize that as the name of a variable so that it will go look for a bucket called friend, notice that the contents of that bucket are Bill, and insert the word Bill into the string called greeting and just replace it. Now, how in the world can I tell Python that that string friend is really a variable name and not just a word? Well, there are two ways, and we're going to look at both of those here now in this video. The first one is a string method called format. Every string in Python has a format method. This is one of the great ways in which Python making things objects is going to help us in the long run. And I do it just like this. So here I'm creating a string. I'm putting it into a bucket called statement. And the string is my friend's name is, and then you'll notice that I've got some empty curly brackets here. That's the placeholder. That's the template placeholder. And then you'll notice that on that string, I am calling a format method. And to that format method, I am sending the variable called friend. And so the result is that Python's format method goes and looks at the value of friend and inserts it into the string where those curly brackets are. So statement now becomes, my friend's name is Bill, exactly in the same way that I wanted it before. And now you'll notice that we've dodged a bit of a problem, haven't we? I picked this example on purpose because the first occurrence of friend is just an ordinary word, and so Python will leave that alone. The format method doesn't know anything about the name of the variable. Well, it doesn't know anything about the name of the variable that we're sending it, and it doesn't go in and kind of willy-nilly just start replacing occurrences of friend with stuff. I need those curly brackets as a template placeholder to tell format where to put some data. And in fact, I can do this with as many values as I want to. So here's just another little one. And my greeting here is, hello, empty placeholder. Have you met? Empty placeholder. And you'll notice that I am sending to the format method here 2 values. The first is called name and the second is called friend. So when I print that out to the screen, or if I just echo that out in the Python interpreter, you'll see here I get, right, hello Goofus McSorley, have you met Bill Shakespeare? But the trick to doing this, and the trick to the next one too, is this set of curly braces. And so you'll notice that Python sees the curly braces, format looks for the curly braces, and it will remove the curly braces, but place the value of those variables in at that placeholder. Very convenient. Now, string formatting is really, really, really powerful, and at the end of the video here, I'll give you a website that you can go to and look at. But one of the things I can do with it is I can start to format all kinds of data with this formatting technique, and in fact, numbers are one of the most common. So here, for example, I've brought a new library called Math into my Python environment. And that library called Math understands what the value of pi is, so that I don't have to type that in. Here it's the 15 digits. We all know pi is a transcendental number. It goes on forever and ever and ever and ever. So this is just a 15-digit representation. But what I can tell Python to do is to say, okay, I'd like to print out the value of pi, but I only want 3 digits. And so inside those curly brackets, I can put some formatting codes. Those formatting codes always start with a colon, and then you'll notice that I have 4.3f. And what that says is, to Python, I want 4 total digits, but I want 3 after the decimal point. And the f actually stands for a floating point number. We can put a D in there, and we can put all kinds of other things. We can convert numbers to binary and octal and hex, and we can do all kinds of things here. It's very, very, very powerful. So here's what I'm saying, is that I want 4 digits total, 3 after the decimal point, and then take pi and just fit it into that format. Now you'll notice too that the value of pi is 3.1415, so Python is actually accurately rounding off the value of pi, because that next digit was 5, so we round up the 1 to 2. Python's very smart about this stuff. Now let me digress for just a moment. The F here stands for a floating point number, and I want to just take a quick digression to tell you what that means. That older computers, and I'm thinking, 1950s to World War II, even earlier, always represented numbers in what we call a fixed point system. And here's a good example of that. This one has 10 total digits with 6 after the decimal point. And one of the weirdnesses that you'll notice about this is that the computer needs to zero fill that number. So if it needs to make up digits in front of the decimal point, then it will add zeros in front of it. If it needs to add zeros to the end to fill up the total number of digits that we've specified, it will do that as well. But for a long time, this is the way that computers always stored numbers. Now, it's not uncommon that you might see this still continuously, and money is a terrific example of that, because if something is $5.10, we don't really write down that it's $5.1. Now, technically, that wouldn't be wrong, but we're very commonly used to seeing money as having 2 digits after the decimal point. And so this is another example, kind of maybe a hybrid example perhaps, of a fixed point number. However, when they invented floating point numbers, what that really meant was that the decimal point could float anywhere in there. It wasn't the case anymore that every number that we stored had to have, say, 10 digits with 6 after the decimal point, right? I could have, what is that, 5 digits with 4 after the decimal point, or 2 digits with 1 after the decimal point, or 3 with 2 after, right? Or if I could do it with 0 even, I could have like 1254.0. And what that means is that the 1254.0 is a floating point number and not an integer, right? An integer doesn't have anything after the decimal point. Now, for us, technically, all that really means is that under the hood, the computer is storing that number in a different way. But for our purposes, that doesn't really matter. We don't really want to go too far down that sort of hardware. We don't want to get, as the programmers say sometimes, we don't really want to get that close to the metal here. But this term actually started in the 40s, 50s. To be honest, it might even have started earlier than that, in the 30s. So this is a very, 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 very old term about a floating point number, and it's one that still exists, and we still see it in Python formatting strings because that's F stands for floating point. All right, end of digression. What else I want to say about this, though, is that when I change the way that I display or represent a number, I am not changing the value of the variable at all. The value of that number or the value of that variable always remains unchanged. So here, even though I'm displaying pi as a 4.3 floating point number, the value of pi still has, according to Python, these 15 digits after the decimal point. My decision to display it as 4.3 floating point has no repercussions on the value of pi that Python knows. So I can display things differently than what that value really is inside a variable. And that's an important thing to remember when working with strings. So that's one technique. The second technique here are what are called F-strings. F-strings are it's one of the newer ways. In fact, if you're running an old version of Python 3, I think maybe before 3.6 or so, you don't have F-strings. So F-strings are pretty new, and I just want to show those to you really quickly because I think they're pretty cool. So again, here number one is the traditional format method. That belongs to all strings. But down below here now, in number two, this is the F-string technique. And you'll notice that I put just literally the letter F in front of the string. I still have curly brackets at the end, but now I put the variable name inside of curly brackets. So this is the F-string technique. I lead with a preliminary F, and then somewhere in the string I can put curly braces, and inside the curly braces put the name of the variable. And obviously I can do this as many times as I want to. I could have as many curly braces with as many variables as I wanted to in there, and that's totally fine. Now what I will say is, even though this looks weird, this is really actually common in Python. Python has a number of string prefixes, a number of prefixes you can put in all kinds of places. Later, towards the end of the semester, we will make strings with an R prefix. This is when we get to some string pattern matching templates called regular expressions. The R here doesn't stand for regular expression. R stands for raw. So later we will see what it means in Python to write a raw string and why we might want to do that when we're using these other kind of template pattern matching systems. One that you probably won't see anymore unless you go on the web and start looking at things is a U prefix in front of many strings. That meant that that string was a Unicode compliant string. Unicode is a character set that contains every possible character on the planet. And even actually, believe it or not, Klingon. Klingon is in there too. Although the Unicode Consortium doesn't recognize that as legitimate, but all the Star Trek people put it in there anyway. Now, I say that this is old and we don't use it anymore because Python version 3, which we should be using, every string is Unicode. But in Python 2, that wasn't really the case. And so I could force Python 2 to use Unicode if I prefaced my string with a U. But again, you'll not see that anymore. If you see it on the web, that is a sure sign that somebody's using Python 2, and you can just ignore it, and you don't need to remember that at all. All right. So as I said, the string formatting techniques are incredibly powerful. There's a ton of different ways that we can control our output. So what I would do is go to this one. This is a really nice intro, pyformat.info. I would take a look at that and just browse your way through it. Every time you need to work with string formatting, just go to this place and you can find it. All of those codes like colon, 4.3f, those sometimes might be a little bit difficult to remember, and so this pyformat.info will give you a ton of good information about that. All right. Well, let's move over into the Python interpreter, and we'll just play with this a little bit so that you can see a little bit more closely how it works. All right, here we are in the terminal window, and I'll get into the Python interpreter. I'm doing green today. Apparently I'm in a green mode. Let's take a look at some of the things that we were playing with strings. And in fact, one of the places that I would like to start is with a little bit of a dodge that you may have noticed, but I would like to revisit that here again for just a second. I'm going to paste this. Remember, I created a statement string, and the string was my friend's name is, and then there's a placeholder there. I'm going to call it statement again. I'm just going to call it S and just make my life easier for typing, so I hope that's okay. Now, you might notice a problem that is about to occur here. So if I try to make this assignment in Python, Python says, yeah, you've got a syntax error here. And here's what the problem is. When Python looks for the string to insert, it says, okay, well, you're starting with a single quote. Got it. That means I continue until I see the closing single quote, which is right here. The single quote and the apostrophe for Python are the same thing. This is why if you start working with curly quotes in the terminal window like this, you're going to have a world ahead of you. So we always use those so-called straight quotes here. Now, it says, okay, the string is my friend. And then, after the string is over, you're doing this weird thing. I don't know what S means. S doesn't have any meaning in Python. And so, sure enough, that's where Python thinks my error is, my syntax error. Now, in the video, I dodged this problem by making the terminator of the strings be double quotation marks. So I start with a double, and then that apostrophe after friend does not goof up Python, and then I end my string with a double. That's totally legit. But I'm going to show you another way to do it. I'm going to come in here, and I'm going to put a backslash in front of that apostrophe. And now I'm just going to hit return, and you'll notice that Python says, yep, that's totally fine. And there it gives me the doubles. Here's what I've done. Right? This is a meta character that says it's the beginning of a string. This is a meta character that says it's the end of a string. What I have done with the backslash is I have told Python, do not interpret this as a meta character that is the beginning of a string or the end of a string. Instead, that is a mere mortal apostrophe. It is a mere mortal single quote. Do not treat it as a meta character. Do not treat it as special. Do not do anything about it. It's just a quotation mark. That's all it is. And don't do anything else. Now, we have seen this before, right? So let's do a new statement. Like we've seen this before in that we would say my for oh gosh, it's hard to type. Now I can put a tab in here, can't I? Or even I could be even fancier. I'm going to put a new line and then put a tab in. Now that backslash says to Python that these are not a mere mortal N or T. In fact, these are special characters. They are now meta characters, superhero characters. Backslash N means a new line. That's a return. Backslash T means a tab. Right? So I can take some mere mortal characters and convert them into superhero characters or meta characters with a backslash. But I'm also allowed to take special characters, special meta characters, and convert them back to mere mortal form with a backslash. Right? Oop, what did I use? This is so hard. Oh gosh, I don't even have a format here. Let me do that. All right. So let's do this. So let's do new S. Oh gosh. It's a hard day. There you go. So my friends are, and then you'll see that I still have the backslash N and the backslash T there. But if I print this, so let me just hit the up arrow, and then I'm going to sneak to the front of the line, and I'm going to print, and then I'm going to sneak to the end of the line, and I'm going to put another parentheses on there. Now you'll see that I get the new line and actually the tab, right? So that's great. So again, this backslashing, we call it an escape, or I am escaping that single quote. This is a way that we can work with those weird meta characters, and then we can convert them. You may have even asked yourself, how do I put a mere mortal backslash into a string? And because by definition, the backslash is to Python a meta character. So we have to escape it. It gets a little complicated down there. Let's take a look at that math one. Here I am again in the Python interpreter. And the first thing I need to do is import a library, or we're going to call it later a module called math. Now, one of the things that we're going to learn is that Python runs lean and mean. So Python doesn't automatically load everything that it knows every time that we start Python. So there's a library or an external module called math, and inside math there is a value for pi. And in fact, you probably were thinking, hey, we learned how to do a directory on something. Can we look at do a directory on a library or a module? And the answer is we sure can. And by golly, there you go. There's the value of pi right down here. I notice there's all kinds of math stuff in here. There's logarithms in here. There's some trigonometry stuff, truncation, remainders, like just all kinds of factorials, some mathy kinds of things that Python says, hey, I'm hedging my bet. Generally speaking, I bet you're probably not going to want to do logarithms. And so I can do them if you ask me to, but out of the gate, I'm not going to do it. So, well, that's okay. Now, let's take a look at formatting string. I just copied this and pasted it here again. You'll notice that I can use weird symbols like pi here because Python is always Unicode now. So any character, if I can figure out how to get it in there, that's terrific. I can bring it in. So now my statement is going to be the value of pi to 3 digits is. This is exactly what we saw before, which is colon 4.3 floating point number. And I'm going to format the value of math.pi into s. If I ask it for s, you see the value of pi to 3 digits is 3.142. So if I needed to change that in some way, right, I could say, let's do, I don't know, 6, right, 6 after the decimal point, but that's going to give me about 7. So let's try that. There's pi to 6 decimal places. Now, what else is interesting about this is if I wanted to do something and simulate those fixed point numbers, I can actually do that really simply by putting a 0 in here. It's a 0 and not an O. And then let's just do, say, 10. So now I'm doing 0, 10.6 floating point number. And now I get those leading zeros in the front end, right? So that's a way that I can kind of simulate that. So you can line up things like if you're doing an accounting thing and you need to have columns of numbers done properly, all of that seems legit, right? All right, one last here. The longer one, I've decided to write that in my text editor and paste it. So this is a really interesting one because we talked about money a little bit, and so that's going to be some sort of point to F, right? Floating point number, 2 digits after the decimal point. But when I'm working with money, I often want some commas in there as a comma separated, to separate all of the thousands, right? So my formatting string here is actually the colon, which is always required, followed by a comma, which tells Python to use commas, and then point to F, which is the floating point number. And I'm just sending it as a random number here. That I bought a really, really expensive widget this time, and so you can format numbers like this as well. All right, well, I'll let you go play with that, but I just wanted to say that this formatting string technique, any technique that you find, is incredibly powerful in Python. And even though they might be slightly difficult to remember, sometimes I have to go look them up all the time just to see what I need or what I want. But find a good resource on the internet. Just remember that or bookmark it, and then anytime you need it, you can go back to it. But don't fear this string formatting technique in Python because it's incredibly powerful. All right, thanks.